So today we're going to be looking at a bunch of different shapes and talking about how to find the area of those shapes. An area is the space on the inside of it. Some of this will be review from some things you did in 6th grade, maybe even earlier, and some of it will be kind of new. We'll talk about circles, which is the 7th grade topic, and we'll actually start to discuss pi and how to use pi on your calculators. But first shape we're going to start off with today is a parallelogram. Now, the one distinction of a parallelogram, first of all, it's 4 sides. And what makes it a parallelogram, you see the word parallel. It has 2 sets of parallel sides. And these are always the opposite sides. So the sides you see across from each other. So on this side of the paper, we're going to kind of put some examples. So parallelogram in general, a lot of times we think of this tilted rectangle as a parallelogram. Okay, because the opposite sides run parallel to each other. They're going the exact same way. They're never going to cross. Now in a parallelogram, for that to be true, the opposite sides are always going to be equal. So let's say these sides are both 8. And let's say that these sides are both 9. It's kind of like a rectangle. Almost looks like a square, and it could be a square that's kind of tilted. If it was a square that was tilted, if all the sides were the same, this is still a parallelogram because opposite sides are parallel, top and bottom parallel. Okay, all the sides are equal, all the sides are not equal. These are still both parallelograms. This is like a rectangle tilted, and this is like a square tilted. Now this is actually called a rhombus. This is just a parallelogram. Now, you can have a square. A square is a parallelogram because if you look at it, opposite sides are parallel, opposite sides are parallel. So if this is a square, all sides are the same. Still counts as a parallelogram. You would have 4 90-degree angles. When they're tilted like this, these are not 90. But in a square, all 4 angles are 90. All 4 sides are the same. And you could just have your basic rectangle. Opposite sides are always equal in a rectangle. We're just making up numbers here. You also have all 90-degree angles. So any 4-sided shape with all 90-degree angles, that's a rectangle. So a square technically is a rectangle. Square is a rectangle because it has 4 sides, 4 90s. Okay, and it's parallelogram. Opposite sides are parallel, opposite sides are parallel. Railroad tracks, never going to cross even if you extend those sides. So all 4 of these shapes are parallelograms. They each have a more specific name, at least these 3. So since all of these are considered parallelograms, when we go to find the area of them, it's going to be the same formula. So area equals, and you may know this from a rectangle. If I was going to find the area of this, I'm just doing 3 times 10, it's 30. If I was going to do the square, it's 4 times 4. So some people will say length times width. Okay, and that works for a rectangle. It also works for a square. But when we get over to these parallelograms that are leaning, you can't just multiply the sides together. So in this parallelogram here, I can't do 9 times 8. All right, I'm going to actually be multiplying the base times the height. So area equals base times height. So on a regular rectangle and a square, the base and the height are the sides. They are the length and the width. So you just multiply the sides. But when you get to these ones that are leaning, the height is this distance. And that's not going to be 8. It's a shorter distance than 8. Okay, so the height is dropped straight down from the top 90 degrees. All right, and that's the height. And then this would be the base. Same thing here. The height gets dropped down. Okay, so we can't say length times width. That is true for a square and a rectangle, but if we want a formula that works for all of these, it's the base times the height. And in a square and a rectangle, the base and the height are the sides. It is the length and the width. Okay, the next shape we're going to look at is a triangle. We all know what a triangle looks like, but they come in all different shapes and sizes. Now, let's think about where a triangle actually comes from. They come from a rectangle, actually, or a parallelogram that's cut in half. So you take a rectangle or a parallelogram and you cut it in half, and you end up with two triangles. And so if this formula was area is base times height, remember area is how much space there is on the inside. So this is just now half the size of the rectangle. So I just need to take half of this formula. So the formula for a triangle is literally 1/2 base times height, because the triangle takes up half of a rectangle. Now, when we do base and a height of a triangle, sometimes it can be the side lengths. If this is a 90-degree or a right triangle, then here's our base and here's our height. And those are interchangeable, because if I flip this, you may call the other one the height and the other one the base. But since we're multiplying them together, it doesn't really matter which one you call which. But let's say we don't have a triangle with a 90 degrees. Let's say we have an equilateral triangle. Okay, this could be the base, but the height is not one of these slants. Just like up here, you don't measure a height on a slant. When you go to the doctor and they measure your height, they go to the top of your head straight down, not off to the side diagonally. That doesn't make sense. But a lot of times students will want to use the side length as a height, and it's not. The measurement is how far from the top to the bottom. And you don't measure that on a slant. You measure it straight down 90 degrees. So the base is this 10, and the height is whatever that length is right there. And there's ways to find it if you need to find it, but most of the time, and what we're looking at right now, they're going to give you that height. But you need to know, if they give me this number and the side length, which one is the height? It's this one. Okay, look for the 90. Wherever the 90 is, that's going to tell you the height. And the side that it hits is also going to tell you the base. The base and the height will always hit at 90 degrees. Sometimes it's the side lengths, like in a rectangle, a square, or a right triangle. But a lot of times the height has to be given somewhere else because the sides aren't hitting at 90. So think about an obtuse triangle, big obtuse angle, connected. Okay, this is not a 90. So the base is over here. Let's call this 5. Let's call this 11. You can call this whatever you want. Let's just call it 8. But that's not the height. The height is how high is the top of this, which gets measured straight down to the ground, if you want to think about it like the ground. 90 degrees. This is the height. How far from the top, straight down. So anytime you're looking for the height in the picture, you don't just grab any old number. You look for the 90 degrees. The height is always going to hit the base at 90 degrees. So this would be the height, and the base would be 5. Okay, and there's heights that could be drawn different ways. We could draw a height like this. This would be the height, and then 11 would be the base. Okay, because this height and this base are hitting at 90 degrees. And the same could be true here. So there's more than one base and height in a triangle, but they're all going to multiply to the same area, because this amount of space that it's taking up never changes. So this height multiplied by 11 and this height multiplied by 5 are going to give you the same answer. So it all just depends which height they give you, which base you're going to use. Students often get stuck on the fact that a base is the bottom. Well, the base isn't always the bottom if I spin this different ways. So the base is whatever is hitting the height at 90 degrees. So you're always looking for that 90. The two lines basically that hit at 90 are going to be your base and your height. Next shape. Trapezoid. Just like a parallelogram, it has 4 sides. And there are some parallel sides, but only one set. One set of parallel sides. So if you think about a parallelogram, both opposite sides are parallel. In a trapezoid, only one set. So your basic trapezoid, your cookie cutter trapezoid, tends to look like this. And you've seen shapes like this before probably. Now the top and the bottom are parallel. Those are your railroad tracks. They're going on forever. If I extended these, they're never going to cross. They're parallel. But the left and the right side are not parallel. That's how come this is not a parallelogram, because if I extended these sides, they will cross up here. Okay, so they're not parallel. So a trapezoid has one set of parallel sides. Parallel is actually represented with little arrows in a picture sometimes. So these sides are parallel, these sides are not. You can also see trapezoids in all different shapes and sizes. This, for instance, is a trapezoid. The top, the bottom are parallel. Never going to cross, even if I extend them. But this side and this side, okay, they are not parallel. They will cross if I extend these lines. Maybe this is even a 90. Okay, still a trapezoid. Top and bottom are parallel. The other two sides are not. Formula for this. 1/2 base 1 plus base 2 times the height. This is actually a very similar formula to the triangle. If you look, you got the 1/2 at the beginning and you got the height at the end. The only difference is a triangle only has one base. One of the sides is a base. In a trapezoid, there's two bases. Okay, and it's your two parallel sides. So we actually add them together. So this 1 and this 2 are not numbers we're going to use. This is just telling you there's a base 1 and a base 2. It actually doesn't matter which one you call base 1 and base 2. You could label them base 1, base 2 like this, or you could put base 1 on the bottom, base 2 on the top. It doesn't matter. They're going to get added together. You just take this length plus this length. Then you multiply by the height. Now, height is always straight down 90 degrees. So the height in this type of trapezoid gets dropped down like this. In this trapezoid, the height is actually this side length because it's coming down and hitting the base at 90 degrees. And we'll go through a bunch of these in the next set of notes. Last shape we want to talk about is a circle. And we all know what a circle looks like. We're going to draw two circles here. Now every circle is equidistant from the center to the outside. That's what makes it a circle. So like all of these lengths are going to be the same from the center of the circle to the outside. If they weren't, it's not a circle, it's an oval. Okay, we're not going to study ovals. Ovals are very complicated. But circles, where the distance from the center to the outside is the same in every direction, are actually pretty easy to deal with. So this distance from the middle to the outside, that's the same in every direction. That's called your radius. That's an important number we're going to use. You also could take a circle and draw a line through the center all the way across. So it's like a radius going this way and a radius going the opposite way. It stretches all the way across. So it's basically a radius plus a radius because each one of these two lines are going to be the same. Because in a circle, the radius is the same no matter which direction you draw it. But when you put them together and make them one big line, this is called your diameter. You can always find the diameter by adding the radius to itself or doubling it, because it's the distance all the way across. Now there's two formulas we're going to use. Let's start with area, since that's what we've been talking about. And it's pi r squared, the radius squared. Now pi is a number. It's a decimal that goes on forever. It's in your calculator. 3.14 and then a bunch of other numbers. It naturally just exists. It was discovered in circles, and we'll talk further about that later on. But this is not a made-up number. It's something that naturally occurs. And the other one we're going to talk about, the other formula, is circumference, which is pi times the diameter. Circumference is like perimeter. So we've already talked about perimeter of regular shapes. You just add up all the sides. It's the distance around the outside. For a circle, you don't actually have that distance given to you as just a side length. So the way you find it is you take whatever the diameter is, the distance all the way across, and you multiply it times pi. Now this is how it was discovered. People measured around a circle, and they divided it by the diameter on every circle, and they kept getting the same number. So they took the distance around a circle, they divided it by the distance across the circle, and they kept getting pi. It's something that naturally exists in all circles. It's kind of like the ratio, so pi is equal to, think about if I divided both sides by d here. Okay, circumference divided by diameter. Okay, this would go away and you'd be left with pi. So pi is equal to the circumference divided by the diameter of any circle in the world. So if I want to go backwards and find the circumference, I'm just multiplying. So we'll talk further on that. But those are the formulas that you're going to need to know.